Hey there, welcome to the course. And before we dive into the code and the cloud, let's take a moment to answer very important questions. Why should we learn Terraform? So you have probably might heard the term like ISE. It is one of those buzzwords around floating around DevOps and cloud engineering and even automation. So in simple terms, Terraform lets you build cloud infrastructure. Like you will write a few lines of code and you will run a command. Okay, on CLI, you will run a command and your cloud environment will be ready with different services which you need. So this is about Terraform. So it's basically like instead of clicking through like a different screen, like suppose you have to create a EC2 on the AWS, you click on different screens, you just go on the EC2 services, then you enter the name of the like EC2. After that, what you do, you create a security group, all these things. Okay, so instead of doing all those things, we will simply write a code and that we can use it anywhere we want. Okay, so now let's talk about what some of the regions like actual regions why you should learn. Okay, so the benefits basically we will see the Terraform. So first is speed plus consistency. Okay. So let's say you want to deploy an EC2, okay, and also database, okay. So we want to create a like RDS, any relational database like Oracle Postgres, and also you want to deploy a load balancer, okay. So what we'll be doing? So the challenge here is you have to deploy this infrastructure in three different regions. Or more than that, suppose you work in any project. So we have different environments like we have Dev, then we have SIT, system integration testing, then you have a UAT. After that, some are having pre-prod as well. Then we have a production. Okay. And you're a DevOps guy and you want to build this infrastructure. So it's a very time-consuming process. So what you will be doing, you will write a basically a Terraform code, okay? And that code you can use it to deploy in all these three environments, not three, more than three, okay? So you can use that everywhere, okay? So it's just like write once and use it at multiple places. And also let's talk about the next reason we have that is version control. Okay, so it is just like the application code, like we deploy the application code in the Git and then we have different versions of it. So if something goes wrong, then what we do, we just roll back and we go into the previous version. So that also you can do with the help of Terraform. You can integrate with the Git. Okay. Then the reason three we have that is cloud support. What does it mean? We have different cloud providers like in a market. If you see around, you will hear this only AWS, you will hear GCP, then you will hear about Azure. So with the help of Terraform, you can connect with all these three cloud providers and you can create your infrastructure on any of the platform or any of these cloud provider. Okay, so this is the some of the three regions like why we should use Terraform, and also about if we talk about like real use cases, and also companies like Netflix, Uber, all these companies like it creates their infrastructure in the production environment using Terraform. So whether you're a developer or you're in the cloud, you should obviously learn about this Terraform. And in this course, we'll start with the basics, and then we go on like hands-on from day one and slowly build up real-world projects, the kind that actually show up in the interviews and production environment. All right, now before we write a single line of Terraform, let's clear up one key concept like ISC. Okay, it means infrastructure as a code. So don't worry, it sounds a bit complicated, but it's actually a very logical idea. Let's imagine this: you are setting up a new project in AWS, okay, and you have to set up EC2. So we follow some of the steps like we search for that service, then we open the console and click on launch EC2, okay. Then we select the AMI, right? After that, we select the networking settings. We configure like which ports to open, then security groups, and then we hit the launch button, launch EC2. Then it creates a EC2 instance for us. So just imagine this thing like every single time you want to do this, okay, and that too for the all the different environments where the configuration will be same everywhere. Suppose we have five different environments like dev, sit, uat, pre-prod, prod, okay. So it's a very painful thing to do the same thing again and again, and because of that, suppose if you miss any configuration, so that is also a big thing, okay, and it's actually a worst thing. So what basically a Terraform do or any infrastructure co as a code tool do, like we can just define a code, okay, we can write a code, and we in that code we can define like create a VPC, then what are the networking configuration we can define, then security thing we can define, and also we can choose any gateway we want to use in our infrastructure. So all these things we can define into a code, and yeah, we'll get our infrastructure ready. And the very beauty thing is like it's repeatable, and also as I mentioned, like you can do the same thing in all the different environments. So you have to write once and use it at multiple places. So what IAC does, so it turns your infrastructure into code, which means you can treat it just like your app code, test it, review it, and automate it, and that's it. And tools like we have different ISC tools in this course which we are going to talk about the Terraform, but other tools are also there like CloudFormation. It's from AWS. Then we have from GCP also like Google Cloud Deployment, some tool we have, and also we have some Pulumi tool. Okay, so we have different types of tools for this thing. So we are basically going to focus on this Terraform. So in short, infrastructure code is nothing but automation plus consistency plus speed, yeah, and also traceability. Hey everyone, so in this video we are going to talk about how does Terraform actually work. So basically the topic is working of Terraform, how it works. So the thing is like think Terraform as a translator between your code and your cloud provider, whether it's AWS, Azure or GCP. So we'll be writing a code and this code will create an infrastructure for us like servers, databases, storage buckets and so on. So it can be any cloud provider like either AWS, Azure or GCP. Okay. So what we do basically, so we start by writing a .tf file. So we create a file with the .tf extension for any Terraform, okay, Terraform file. And in this file, we describe our like requirement, like we describe we need one EC2 instance, one RDS or S3 bucket we need. So basically we describe the infrastructure in this file. So after that, we run a few commands. So the command which I'll be telling, keep in mind. So Terraform init. So these are the basic commands which will be used for like every time we'll use this. So Terraform init, it is used to initialize the project. Okay. So once we will install the Terraform, then we'll see it. So it is used to initialize the project. Next we have Terraform plan. Okay, what it does, it is used to preview what changes Terraform is about to make. So basically, preview thing like what are the changes going to happen if you will run this particular command. Then we have Terraform apply. So as the name suggests, what it will do, it will basically provision or change your infrastructure or create your infrastructure. So this you can write as provision. Next we have a Terraform destroy. Okay. So why destroy? Suppose you don't want to use your infrastructure after your after some time, like after your shift is over or something like that. So if you don't want to use it and you want to save cost, then in that case you will use the Terraform destroy. What it will do, it will tear it all down. Okay, whatever infrastructure you have created, all will get vanished and deleted. So what interesting is, so interesting part here is Terraform keeps track of what's deployed using something called a state file. Okay, so this is one of the important concepts, state file. So in this, what happens like it's just like a memory. like you can say as the Terraform memory. It knows what resources it has created, and so that it doesn't create any duplicate resource and it doesn't delete any wrong resources. Okay, and it all happens through a provider plugin. So basically we have a provider plugins like we have AWS plugin, Azure and GCP all. So okay, so it works with the provider plugins. We'll see providers in our next classes. So the basically the cycle I will tell you is, the cycle is first we'll write the code, okay, Terraform code, then we have a plan, then we will be applying, then we'll get the infra, then we can track it via state file. Okay, simple enough. So don't worry, we'll do this live in the next video. So but first we'll install the Terraform, and that also in the next video we'll see. Okay. Hey everyone, in this class we'll see how we can install Terraform in Linux. So I'm using a Linux Mint in my virtual box. So you can also install any Linux distribution, even Ubuntu or Linux Mint, and then you can use the same command. So basically you have to go onto the Google and search for this install Terraform. You will get the first link, just click on it and you will come up on this page. Okay. So according to your OS, you can choose the installation. For macOS here you can see, or even on Windows and the Linux we have. So if I'm doing for Linux, so just take the first command and open up your terminal. Yeah, just paste it. Okay, it will take some time. Then we have this wget command. It will install ASIC or GPG key. Let's wait. Okay, it's done. Just do Control Shift 3. Okay, this is done. Next, what we have, verify. Okay, I don't want to verify. Oh, we can verify, that's fine. Okay, expires on 9/1/2028, you can see. Then we have to add official to your system. Okay, done. Next we have update. Just to update. Okay. Then we have the final command, that is sudo apt get terraform install. So just do Control Shift V. Yeah. And it's installing. We will check the version and we are done. Okay, so it is installed. Let me just clear the screen and do Terraform hyphen version. Okay, it's showing me 1.12.2, so that's fine. Terraform hyphen help. Yeah, so here I can see all the commands. So init, validate, plan, apply, destroy, main commands, these and other commands we have: console, format, get, graph, login, logout, all those things. Okay. So finally we have installed the Terraform. So from our next class we will start the actual practical implementation with the AWS. So hello and welcome back. Now that Terraform is installed, and it's time to set up our very first configuration file, and for that we need to understand something called provider. Okay, so what is a provider in Terraform? So a provider tells Terraform, okay, which platform to manage. So what does it mean? So whether we want to use Terraform to use AWS, or we want to use Azure or GCP or GitHub or Docker. Okay, so with the help of provider, we are going to tell Terraform what are the services or which are the cloud providers I'm going to use. So this is a basic layman definition of a provider in a Terraform. Okay, so whenever we write a Terraform file, we define the required providers and all. Okay, so we'll see this in this video, and as we are aware, like in this course we are going to use AWS. So to use AWS for Terraform, we need which provider? I think you might have guessed, that is the AWS provider. Okay, so this way I'm going to define the Terraform file. So before that, we need to configure our AWS credentials, and we need to install the AWS CLI. Okay, so how we are going to do? So first of all, you will go up on this page, installing, updating to the latest version AWS CLI. In that, you will see the Linux section. here I have. So you have to simply just copy this command and you have to just paste into your terminal. Okay, so already I have done. So if you will see here, it will download this v2.zip file, as you can see in the here also command also, and then they install sudo dot slash aws install. Okay, that's a quite easy process. Then after that, what you need to do, you have to just go in your console and go into your IAM user. Then you need to create a access key and a secret key, I guess. Yeah. So you have to go into your users and go in IOS, and here you will see an option of create access key. So here is one access key I have. Okay, then again access key, if I want to create, I will just click on create CLI and do next. So you will get your access key. Okay, after that your next step is to just go in on your terminal and enter the command aws configure. So that also I have already done. So here you will need to you'll be asked to enter your AWS access key and secret access key. After that, the default region name. Here I have given AP South 1, and the output format I have given JSON. Okay. So this creates a credential file on your system that Terraform can use silently in the background. So that file you can see at this path cd tilde slash dot aws, I guess. Yeah. If you do ls-l, so you will find this config and credential. In config, you will see whatever I have defined, like region and the output, and the credential you will see the access key and the secret access key. So in this way, you can configure the AWS to you use for your Terraform. Okay. Now at the next step, what we are going to do, we are going to create a directory. So okay, let me just go into the home path. Yeah. I've already created a directory with Terraform basics, and I'm here no file is there. Okay. So here we'll create a provider.tf file. So we are going to use VI editor. In the next class, we can install VS Code and we can use it. So what we have to do, we have to use Terraform and opening closing bracket. Then we are going to tell Terraform which provider to use. So these are the like external plugins or provider which I plan to use. Okay, and we are defining the version and all everything. So how we can do it, we have to do required underscore providers, and similarly opening closing braces. Yeah, and then we have to give the source, like from where I want to download this provider. So I want to deploy download from the HashiCorp, that is the what do we say, official registry of Terraform. Then we have to provide the version. So version here it will be like equal to, and here we can give it as till greater than 5.0. Okay, so there is some important thing I will tell you about the version itself. Okay, so one more thing we missed here, in required providers we have to give the provider name actually. So we are going to use AWS. So just one closing bracket here and opening here, closing here. Okay, so this is about the required provider. So what these lines say, so basically this one required provider, these are like the external plugins which I told just now, and here we define like how to get it. So we are defining the source, and the version it is telling like which version to use. So here we are just defining the version should be greater than 5.0. So if you are using tilde, so what happens, I will just tell you. If I go here in the screen, okay, if you use tilde 5.0, like greater than tilde greater than 5.0, so what does it mean? Your Terraform will use this from 0 to 9. So you will go max till 5.9. It won't increase to 6.0 or something like that. Okay. So there are different versions. Like if you use equal to in the version, so you are just defining use the same version. If I'm giving like 5.0, it will use the same version. If I do greater than equal to, then it can use version anything greater than 5.0. It could be 6 or whatever. Less than and less than equal to same, not equal to means it won't use that version. And the very important tilde one. So it will use up only to the last octet. So if it is like 5.0.0, it will use 5.0.29. Okay, so this is the thing about the versions. Okay, next to move forward, what we are going to do, we are going to write another block that is a provider. So here we are going to do like here I will tell how to configure this provider, like what to do, what are the operations. So that is being done like this: provider AWS, then write opening closing, and here we are going to just define like this is my AWS is my provider, and for this provider I want to use region equal to US East 1, for example. Okay, so in this way we can define the providers and the required providers. Okay, so once again, what are the required providers? It declares what plugins or providers Terraform should install and from where and which version. In this case, we have HashiCorp and the version we are giving. And next block we have provider AWS. What it do? It configures how to use that provider. Okay, so I hope it is clear. So next, what we are going to do? Uh, One more example, I will just tell you. Like in case of if you have the multiple providers, in that case, how will it work? So just for example, here we have the required providers. Okay, and in that I'm providing like giving AWS some version. Then next we have suppose GitHub. Okay, so in the required providers I given all this information. So like I will tell Terraform I need these providers, and then in provider AWS I'm telling what to do. Okay, or what are the operation we want to do on this. So here I can tell like I want to use region this US East one. Okay, and then for the GitHub I can give like provider GitHub. Sorry for the handwriting, it's I hope you are understanding. Provider GitHub, if you give here we can define our token, okay, or any information like owner or the repo, all these names we can define. So these below blocks are just used to tell what are the things you are about to do in that environment. Okay. So now the next thing what we are going to do, we'll just save this file provider.tf, and just to escape if I using vi and do wq exclamation. Okay, we are done, and the next thing which we are going to do is we are going to initialize. So we are going to run terraform, what, wait a minute, terraform init, and it is showing command not found. Okay, sorry, terraform init, yeah. Okay, so here you can see it is finding HashiCorp AWS version matching greater than 5.0, then it is installing also, and see it is installing 5.1.0. Okay, no, yeah, which version it is? 5.100.0. Okay, let's see. We need to wait a bit. I will just pause the video for now. Okay, so it is done. So you might have also seen the message Terraform has been successfully initialized. So it means everything is ready to go. Okay, so in this way we can initialize, and if you do ls, so provider.tf is only here. Okay, so in the next video what we are going to do, we are going to use this setup to build our very first cloud resource, that is an S3 bucket we'll be creating, and that too without using the UI. We'll be doing it from the code. Okay, so just recap this video. So what we have covered, we have covered our providers. So if I open up this one, yeah, so we have covered providers. So what it means, it is just a plugin, okay, that let Terraform manage external platforms. Then we have declared them like we have provider block. Okay, so we declare in a provider block like which provider to use, like AWS, and then we have AWS configure command and Terraform init. Okay, Okay, one thing is pending. So we didn't see the hidden files here. Okay, so here you can see the .terraform folder. So in that we will see the so many files will be there. We have providers. Okay, then here you can see registry. Then ls all. Okay, I guess here we have HashiCorp. Then here I have AWS. So I'm going inside and inside. So here you can see the version that is somewhere I just saw CD 5.100. Okay, so here you can see it has downloaded this. What do we say? Required provider. Okay, so if I go inside this Linux, you will see Terraform provider AWS. Okay, it's I guess some executable binary. So in this way, we can find out which provider has been installed. Okay. Hey, before you start writing the Terraform code, we need to install the VS Code in the Linux. So you have to just search on the Google install VS Code in Linux and click on the first thing you will be getting, and you will get the here Debian and Ubuntu based distribution. If you're using Ubuntu or any other Debian based distribution of Linux, so you can just click on this and it will download of some file like this. Okay. So already I have downloaded. So what you have to do then after that you just click on this folder, okay? And this is a Linux mint system. So or even for Ubuntu you can do the same. You have to just double click on it, and from here you can directly install this VS Code. Okay. So I have already installed it. You can see it is showing the same version is already installed. Okay, I will just show you how you can do it. You have to just click on this reinstall if you have not. If you have not installed previously, it won't ask for you. Okay. So now it will install the file. Okay, it is almost done. Okay, we'll wait for some time. Yeah. Okay, it is post installation triggered. Okay, it is done. I guess. Yeah, installation successful. Okay. Once it's done, you can just view here in the apps. If you search VS Code, you can find it. And in Ubuntu also, you can check in the app section. So in this way, you can install the VS Code and use it. So hey everyone, welcome back. And in this lesson, we are going to talk about the Terraform resource. So what is a Terraform resource? So Terraform resource is nothing but whatever you want to create in your cloud infrastructure. It could be an EC2 instances, it could be a databases, it could be a bucket, or it could be any like VPC. So any resource which you wanted to create in AWS or any cloud environment with the help of the Terraform, it will act as a resource for the Terraform. So how we do it? So every cloud resource or anything if you want to create, we write in a resource block. Okay. So there is a syntax of resource block. So we write like resource, then we'll providing the name like what we want to create. So it could be like S3 bucket or EC2, anything, whatever service we want to create. And then we give a local name here. Okay, so it will be a local name for the just Terraform for our reference, and then the curly braces. So in this way we create a resources. So now we will start by creating a new file in our project. Okay, so we'll create a file in my VS Code. I have already opened. So in our last class, we have already seen about this required providers and the provider block. Okay, I'm using the region AP South one, that is of Mumbai, I guess. Yeah, if you see here the region, it will be AP South one. Okay, and this is the S3 bucket page, and here you can see I have no buckets for now. So what I'll be doing, I will just open up here. In my VS Code, I will create a new file with the name main.tf. Okay, cool. So now in this we will write a block, okay, with the resource, and also in VS Code you can install an extension of this HASIC of Terraform. If you search Terraform, it will come and you can install. So it will give you some suggestions. So I will just show you how it works. So if I write resource here, so you can see here it came. Now here I have to just simply provide the resource. So in this video I'll be creating the AWS S3 bucket, and then here local name I can give anything S3, okay, or the same, that is also fine. Then here you have to just simply provide the bucket name. So the variable we have here is the bucket, okay, bucket equal to, and here you can give any name. I will give Ayush and 098, and the current time is like 0039, something like that, okay. And then we give the like access control list equal to, we'll give private, okay. So here you can see it is showing in the yellow color. There will be something, we'll see, okay. If I hover on it, here you can see ACL is deprecated, reason it is not written, okay. It's fine. Now we'll see what else we can do. So now what we can do, you have to just open up your terminal from here. If you go new terminal, you have to just click on the new terminal here, okay. And now the very first command which what we had mentioned, or in our last classes what we learned. So the very first command here we have, that is Terraform init, okay. If you do Terraform init, it will, what it will do, it will download the required providers, okay. Then we'll see Terraform plan, okay. So it will show us key what resources is going to be created, okay, just like the preview. And then we'll simply apply. Terraform apply will create the resources, and at last we'll write Terraform destroy to delete the resources, okay. So we have Terraform destroy. So all these commands we are going to see in the action today. So let me just open up the terminal here, and let me just write the first command, that is Terraform init. And it will, you can see, initializing the backend, provider plugins. It will try to install this HashiCorp of AWS provider. So I'll just wait for it, and then you can see like some hidden files, okay. So here you can see like in the dot or something it will come. So we'll just wait for it until it downloads. It takes some 15 to 20 seconds of time. So we'll simply wait. Okay. So till then, I will just simply tell you about this resource block. So this is the resource as previously I discussed. Okay. And this is the resource type. Okay. And then we have the local name, that is like Terraform only. So in Terraform only, we have to provide this. Okay. Now then bucket and the access control, and now we are done. It is downloaded. Then we have to do Terraform plan. Now this will show what are the resources going to be created. So we'll just wait, and it will show us the your infrastructure matches the configuration. Terraform has configured your real infrastructure against your configuration for no differences, so no changes are needed. And no changes are needed. Okay, fine. Why no changes are needed? Okay, because we have not saved the main.tf. Now let's do. Okay, here you can see now. Here it is showing ACL deprecated. You use the AWS 3 bucket ACL. Okay, we'll just use it. We'll just copy it. And then here you can see the best part of this. Like it is going to Terraform use selected providers and all. It is showing okay. And Terraform will perform the following action, and you can see the what action is going to perform. It is going to create the bucket. AWS 3 bucket will be created, and all the other information you can see, like access control is private and all these things. Bucket name you can see here. Okay, so with pal plan we saw the preview what is going to happen. And let me just update this thing. I'll just do Control Shift C and just paste it here. Okay, now it is showing in red. I don't know why. Unexpected attribute. Okay, use the AWS S3 ACL resource instead. Okay, it is going to use the resource directly. Okay, so no need. I will simply use this ACL for now. Okay, so now what we can do, I'll just clear the screen quickly, and I will do Terraform apply. And now it will create a bucket that we can see, and here it is asking to whether you want to create, and do yes. And here you can see apply complete resource one added. Okay, so let me just open up my bucket and reload it. And I'll simply go into the general purpose buckets here. And here you can see the bucket has been created. If I open up, so there is no files here. So simply I can upload and download any file which I want to do. Okay. So in this way you can create a resource. So this is a very basic tutorial for now. So now next we are going to just delete it. So what I will be doing, Terraform destroy. Okay. Hit enter. Okay. Now you have to do, there is no undo. Okay. We have to do yes. And what it will do, it will delete the resource. That also we can verify from here. If I go in general purpose bucket and if I try to refresh here, and then now you can see no bucket is there. Okay, so in this way we can use the Terraform. So let's quickly recap what we covered today. So we covered basically the resource block. Okay, so first was the resource block, how we can define the cloud infrastructure. Then we just created an S3 bucket with that, and you learn about this all our four commands which I told you, like init, plan, apply, destroy. Hey everyone, welcome back. And in last video we created our first AWS resource, that is an S3 bucket. So at that time what we did, we hard coded the bucket name and the region. Okay, so basically in the real world projects it becomes very hard to manage these like names and all. So that's why we have a variables. Okay, so today's class is about the variables in the Terraform. Okay, so what is a variable in Terraform? Just like in any other programming languages, we have variables, like we define our name and we give some value like a equal to 10, b equal to 20, c equal to something. Okay, so similarly here in Terraform also we have we define the variables for the, like we can define the variables for the resource name, okay, for the region, all these things. Okay, so today we will see, we will refactor our S3 bucket code, and then I will show you how you can create your own variables. Okay. So first of all, what you have to do, just open up your VS Code, and these two files we have created, main.tf, in that we are defining the bucket name, and then we have provider.tf, there we are defining the reason. So what we are going to do, we are going to create a variable, in that we will store the values of these, okay, these two. So first create a file with the name variables.tf. Okay, okay, so here what we have to do, we will be defining the variables. So what is the syntax for that? I'll just show you here. uh, it will be like, it starts with the variable, okay, variable, and then we will have some name here, curly braces open, close. In that we can define the description, we can define the type of the variable, whether it's string, int, double, something like that. And also you can give the default values. Okay, so we can give any default value here. Okay, and I will also show you how we can override these values as well. Okay, so let's go here. In variables.tf I will be writing variable, and then here you can say, because of extension we are getting this, so in this we will be writing bucket name, bucket underscore name. It's a simple local variable name. Okay, it's not related to your resource name. Here we will be defining the type equal to string, and I can define the description as it's an AWS bucket resource name variable. Okay, cool. And same, we will be defining another block for the reason. So here we can provide the reason underscore name, and then we can define the type as the string, and the description I don't want to give. And here we can define the default value. Okay, that is AP South one we have in our case. Okay, so in this way we complete our variable file. Then to use these variables, we have to just open up a main.tf file, and there we have to, instead of this bucket name, we can give var
If I do just what, you can see it is giving me suggestion bucket name or region name. So I'll simply select the bucket name. Okay. And even in provider.tf, I will be doing the same. That is var dot region name. Okay. So now it will access those variables, okay, the values of that, but we have not defined the values yet. So for that, we will be creating the another file with name like we give as terraform dot tf okay. In this, we can define the values of those are variables. So we give the name bucket name. So here I can give like bucket name as Ayush 789446123 something like that. Okay, and reason is default, so it will pick the same value, but here we can give the reason and value as well. Okay, AP South 1. Okay, so in this way we can define this. So this file, what you do, this file provides the values to your variables. Okay, so you don't have to enter them manually every time. Now what we are going to do, we are going to run our Terraform plan. Okay, so here you can see it's done. And if I will again do the Terraform apply, it will create a bucket for me. Okay, I have to write enter yes. So here you can see AWS bucket is created. Resource is 1. Okay, so here you can see the private and the name. So in this way we can use the variables. Okay, so now what is the bonus thing in this for this video? Like we can even override our bucket name. So what we can do, if I will do just Terraform apply, and we can give the var equal to, we have this bucket underscore name, and here we can give the any bucket name, like I will give suppose AV789456123. Okay, and I will just try to close the, and I will enter, and I will just open up my yes. And here if I open my console of AWS bucket, so I should have bucket there. Let's go on S3. And if you see here, general purpose bucket. So here you can see the bucket name is now AV789456. So we basically override that. Okay. So in this way, you can even override the variables using this -var and the whatever bucket name you are using. Okay. So now I will simply destroy the resource. Okay. So this is like very useful. Okay. So that's it. And I will see you in the next one with the next video on hopefully on outputs in Terraform. So thank you so much for watching, and I will see you in the next one.
Hey everyone, so far you have written a Terraform code to deploy your S3 bucket, and also you have used variables in our last classes to make the code dynamic. So now in this class we are going to talk about the outputs. Okay, so what are the outputs in the Terraform? So outputs is the main topic here. So suppose in different programming languages, like if you have C++, you have Java, you have Python, in all these languages you might have used different syntax to just print any kind of values which you want to print on the screen. So for CPP we have cout, for Java we have system.out.println. Okay, it's quite a big one. Then in Python we have the print statement. Okay, so similarly in Terraform we have this outputs. So outputs is basically like a print statement. Okay, so if you want to print any information about your resource, for example, if you're deploying a EC2 instance and there we want to get the information about our public IP, so that you can get, in case of S3 bucket, we can get the bucket name like that. Okay, so anything which you want to print on the screen, And if you want to use that value in somewhere, then we can just simply use the outputs. Okay, so we'll just create one output file, and I'll just simply tell you the syntax how it will be. So the syntax will be simply you have to write output, and then you have to write some name here. Okay, open, close curly braces. In description, if you want to add anything, and the value which you want to store there, that you have to write. Okay, so I will quickly show you how you can do it. So just open up your VS Code, and already I have here. So I will be creating the file outputs.tf, right? Okay, we are done here, and I will create the, here you can see by input output. Already I got the boiler code here, and I will simply write the bucket name. Okay, or simply bucket is also fine. And then in the description we can add this is the bucket name. Okay, after that we will add a comma. Okay, and then not comma is not required, sorry, we will just give the value, and the value I'll be using this one. I have this AWS3 bucket, and then here also if you see in the main.tf we have this AWS3 bucket, and this is the name is showing in the second one. Okay, so if I change just this to S3 my bucket, so it will be a clear idea for you. So here you can see in outputs.tf, if I do dot, it will give me my bucket. Then I give dot, it will show me all the information which I can print. So simply I want to just print the bucket name. Okay, or it's a bucket domain name. If I do just bucket, it will give me some information. Okay, just bucket is also fine. Okay, so in this way you can just simply define an output block. Okay, so here the output bucket name, these first line determines the name of the output, what it will be in the description which we have added, and the value which you want to simply display, okay, or print. So next, the command which you are already aware, the next we'll be adding the, we'll type Terraform apply, okay. So let me just do Terraform plan, I will do first, okay, and then I will do apply. Let's wait. Okay, plan is done. I'll just close it, yeah. Just clear the screen, and I will do Terraform apply. And here I have to just enter yes, enter, and you can see it was the bucket is creating. And now here you can see the in outputs, you can see the output is coming as the, I guess it is the name of the bucket we are getting. And here also in variables you can see the same name, right? It will be where we are defining in TF we have 78945666613. Okay, so in this way you can see the output. Okay, so even if you type here Terraform output, we are going to see some info. And here you can see the, in this also you can see the output of any like variable or not variable, like output blocks. Okay, so that's it, and we will keep quickly see what we covered. We covered about the outputs, okay, and you got to know about how you can define the outputs like this block, and how you can give the value and how it is coming. Okay, whatever resource you have and the resource name you have to type, and here you will be having different attributes. Alright, welcome back, and in this class we're going to talk about a very important concept of Terraform, that is the Terraform state. Okay, so we have this Terraform state. Okay, so in our last class we have already created the resources like this three bucket. Okay, but we have never told Terraform like I want to create an S3 bucket, or I want to delete the S3 bucket. So how Terraform actually handles all these things? So to handle all these things or to keep track of everything, we have something called this, okay, Terraform state. So today's video is about this only. So this will be basically a theoretical video, and just it's for the understanding. So if you understand this concept, so that will be very helpful for your further work. Okay. So let's discuss on it. Okay.
So we are going to do, so we will just open up the our website. Sorry, website I'm saying. Just the code editor, okay? And here you will see the file that is Terraform state. So basically in the Terraform state file, you will get the information about, okay, you will get some info like about like resources, you will get info about the outputs and all the resources about means all kinds of information you will be getting like their ACL and means if it's a EC2 then IP addresses and all these you can get. In case of S3 bucket we are getting the bucket name, everything. Okay, so all this information we will get. So if you see now, actually I have destroyed the S3 bucket, so nothing is here. Now I will just simply do apply, Terraform apply. Okay, so we'll see what happens. So we'll just wait, just type this. Okay, so now you can see the Terraform state file. I'll just close this terminal. And then you can see the resources section we have, and even above you can see the version, Terraform version, and also output you can see the resources, you can see the S3 bucket and all the information about it, like ACL is private, bucket domain name, bucket name, okay, like grant ID, permission, full control. So basically it will be like Terraform state file in this all the information about your resources will be present. Even you can see then which region that uh, resource has been deployed. Okay. So basically what happens whenever you use the apply command, okay. So the basic function of Terraform state is like what needs to be added or what needs to be deleted. So now I tell you what happens basically when you use apply. So whenever you use the uh, apply command, so it checks like what exists. Okay, now. So from where it checks from the Terraform state file. Okay, and versus it checks what's present in your TF file, like main.tf or those whatever files you have. So it just compares the previous version to the current version, and then it like comes to a decision to do what needs to be done. Okay, based on the command. So if you're using apply, so it will check like what needs to be done. Do I need to create a resource or what? So in this way, Terraform state file works. Okay, and be careful about this file. Like if it gets deleted, then Terraform will be basically lost its memory, and it will be if you use an apply command, so it will create everything from the scratch again. So you might be get into a trouble where it will be creating some duplicate infrastructure. Okay, and we have already covered like where is it is stored. So basically, it's stored into the local storage if you're using locally. But in case of any like if you're working in a team or somewhere in a DevOps team, so they store this file into a remote backend. So on that we will have a separate video. So basically that state file will be stored in something S3 bucket or somewhere in Git, and then from there we will be managing that. Okay, so that we'll see in the next video and other videos. Okay. Hey everyone, welcome back, and I hope you're enjoying this course so far. And in today's session, we are going to talk about Terraform data source. So it's quite a good concept which you should be aware. So what is the Terraform data source? So far, basically, we have created some resources which we want to create. Like we have created EC3, we have created only, but we will be creating like EC2, RDS, VPCs, all those things. Okay. So what Terraform data source, what it does? So basically, if you want to use some existing resources, suppose in EC2 you can have different security groups. In VPC you can have the different subnets, or you can have the multiple VPC. Okay, so if you want to use some existing resources, in that case you can use the Terraform data source. So what is the basic thing? Simply Terraform data source used to use existing resources. So it's just a read only. You Terraform data source will not create any resources. It will simply read some resources, give you some IDs and all, and then that IDs and all you can use it in your current infrastructure or in your current resources. Okay. So let's move on to the practical side. I will just let you know what we are going to do today. So basically, we will have an EC2 instance. Okay. Suppose this is the EC2 instance. Okay. And for the demonstration purpose, I have created security groups. Okay. Security group 1 and security group 2. So one is like this is one is by default and another one I have created with the name test. Okay. So what we are going to use, so in EC2, we are not, while creating EC2, you use to create new security groups. But what we are going to do, we are going to use the existing security groups, okay? And we'll be providing subnet ID and all that all will be, we will do hard code, okay? So now let's begin. So I'll be all doing into the today in different region actually. So the region will be the US East one here you can see. And this is the security group which I'll be using. Okay, if I go here in the security groups, so you can see two security groups I have. One is test and one is default one. So test one I will be using. And AMIs you need to create instances. Whenever you click on launch instances, you will see AMIs and also already two instances are running. Let me just quickly terminate these two. I don't want. Okay, yeah. So AMIs, if you click on launch instances, okay, so you select which operating system or what you need. So that is basically the Amazon machine images here also you can see. So it's staying with time. Okay, so this Amazon Linux I'll be using. So the AMI here it will come 08 something. Okay. So now let's move on and also if you are changing the region name and all, just make sure to change the bucket name also. So I will be changing the bucket name as well. So you have to change in variable TF wars US East 1. Okay, just I'll change some variable bucket name also. I will be adding some numbers 787. Okay. Save it. Then variables.tf. The default is AP South, but I will be using US East one only. Okay, and then in provider block outputs main.tf, anything is there. Okay, let me just clear. Okay, in main.tf, what we are going to do, we are going to create first a resource block for the EC2 instance. So the resource and the AWS underscore instance. The name will be EC2. After that, here you can provide the type, instance type. So instance underscore type, it will be the t2.micro as we don't want to spend some money. Okay. And then AMI we will be using equal to control V. Sorry, not that one. This AMI I can copy. Okay, we are good to go now. Yeah. AMI is also done. Then we'll be having some tags. Okay, so the tags, it could be key value pair, like name, we can provide any name, and name value will be the EC2 Terraform as a like this something. Okay, so let me just change the spelling. Okay, name is done. Then we'll be providing the subnet IDs. That also we're going to hardcode for now. Okay, so subnet ID we can get it from the VPC console. Okay, here subnets is there. You can use any subnet which you wish to use, and here we have multiple, so I will just going to copy the subnet ID. Okay, control V, done. After that we are going to use now the data block. Okay, so data, and then here we have to use for the security groups. Okay, security group is done. Then here you can just give it as some name, like you can give any name like SG or something. Yeah. And also, yeah, there are two ways to define use the this data block. One, you can use the filter, and another one is simply you can just hard code it actually. Okay. So the filter, basically what I'm trying to say is, suppose here we have security groups, okay, multiple security groups, and so this is S3, here it is. Yeah, test and default is there. Suppose if you want to, you have multiple tens or hundreds of security groups, and you don't know the ID, and but you know the name. So you can just filter security group by name. So you have to filter in such a way you should get only one single record. Okay. So two ways I will just show you how you can define. One is you can just give ID equal to and give some whatever ID is there. Otherwise we are going to use the filter. Right, it's coming red. Let me just remove it and again write data, then AWS underscore security group, then name SG. Cool. Okay. Then I will be using filter here. In filter also name based on what you are going to filter. So it is the group name. These information you can get it from the registry, Terraform registry. Okay. Name, and then you have to provide the values. So we are going to give in values the test. So here it accepts string. So test or test, I guess test only. Yeah. Okay. So we are done with the now data source. Okay. So in this way you can define, and another way was to simply do ID equal to and give the security group ID. Okay. So now let's save it, and I will simply do init also today. We'll see init where it is. Okay. It is done. We are going to now plan. Here we can see what it is going to create. Okay, plan me, you can see two to add, then apply. And yeah, we missed one thing. We should print the public IP also. So that also will be going to do. Let me just do yes here. Then I just add outputs. In output, we can give the like security group. So in security group in value you can add like data dot id. And one more mistake we did, actually we have not added security group in the main.tf file. We created a data block, but here we didn't add. Okay, it's done. We'll simply just destroy it and again create. So you have to just simply add here security groups string and the data, and here you have to give the dot id. Okay, so in this way it will be created into that security group. Give yes. Okay, let's go into the output where it is. Yeah, so security group we are printing, then output we will be printing EC2, IP we are going to print AWS EC2 instance dot public IP, not DNS, public IP. Yeah, so two values will get printed. So here we can see instance is getting destroyed. We can see here also launch instances we have, then just go back. It's taking time actually. Yeah. All are terminated. Okay, all are in terminated state only. Okay, now we will again plan, and we'll simply do apply. Apply. Now let's check here anything is there. Okay, now bucket is getting created. So we changed the bucket name because sometimes we previously created that bucket into the AP South one. So that is the global name, and if you don't delete it, so it will be a issue if you are creating into another region. So there is some global names issue comes. So that's why we changed the name. Okay, so still creating. We can see here on the console if any instance is pending. Yeah, here you can see it is in running. And if I just select it, an instance ID you can see, public IP you can see, and here also you can see the EC2, the public IP here, and the security group you can see, and the bucket name. So all information we got, then the IP same 154.198.255.184. Yeah. So and this way we can create EC2 instances, and if you go for the security, so the security group it will show. Here you can see the test one, the same security group ID also we can see 6E7. So here also we have 6E7. Okay. So in this way you can use the data source to use any existing resource. So that was this was a very quite basic example as we use security groups. So in our next classes, hopefully we will be creating some mini projects and some major projects. So yeah, that's it for now, and I will see you in the next video. Thank you so much for watching. Hey there and welcome back to the course, and in this video we are going to unlock the very important feature of Terraform, that is the Terraform modules. So in this class we are going to cover this concept only. Okay, so what is Terraform module? So in a very simple terms I will simply explain you, like so far we have written all our Terraform code in one single file, right? So we have written our code for S3 and EC2, so all we have written in the same file, and even we can say in the same folder, right? But in real world infrastructure, which grows very fast, suppose you work in any in a team, and there is a requirement of create 10 EC2 servers or 5 S3 buckets or 5 VPCs or RDS. Okay, so databases. So there is a requirement of multiple things at once. So in that case, you are not going to just copy and paste the thing. So that's why we have a Terraform module. So Terraform module, just like you can consider this as any programming language function. So we have some functions, we write some code there, and we can call this function multiple times, and it will execute that much number of times. So similar way, we are going to create a module, okay? And according to the requirement or the number of times which we want to create that resource, we are going to simply call it first, second, third time like this. Okay, so that's a very quick introduction of module. So I will simply explain you how the what we say directory structure will be. So for us, the current directory structure you can see here we have this Terraform basics. Or if I just do okay, I was deleting some resource. Let me just destroy it. Okay, I will simply explain you here. Okay, so we have something slash home. I use sorry for handwriting. Okay, in that we have Terraform basics, right? This we have. After that, what we have in that we have main.ts, right? After that we have outputs dot tf. Then we have some tf4s like terraform.tf4s and so on. Okay, so these are like for now is the root module. Okay, in one file only we are writing everything. So these are like root modules. Okay. So now for example, I have to create some modules, okay? Suppose for example, I have to create an S3 bucket module. Okay, so how it will be? So this is the Terraform basics directory. Inside this directory I will be creating. In this directory, I will have my own main.tf. Here I will have my outputs.tf, specially for that particular resource for S3 bucket if I'm creating, okay, or variables.tf, and then in this we are having already main.tf, we are having provider, we are having outputs, we are having terraform.tf first. So these will act as the root module. Okay, so too much of theory for now. Let's do hands-on now. Okay, I explained you the folder structure. Just we have to just work on the module thing. So basically, we are going to create an S3 bucket module. Okay, so let me just clear it. Okay, so I was just explaining you the right structure, right? So if you do the PWD here, you can see Terraform Basics is under Ayush, and inside Terraform Basics we have all these folders: main, output, provider, sorry, folder and files. Okay, .tf first, all those things. So now what I'm going to create, just clear the screen and create a directory s3 underscore module. Okay, inside s3 module we have nothing. Okay, here also you can see directories created. Here we'll be creating three files: touch, main.tf. Then we'll be creating outputs.tf, and we can create variables.tf. Okay, so these three files has been created, and from the old main.tf, we are going to simply comment out the bucket things. Okay, we are not going to use it. For outputs also, we are just going to comment. Okay, EC2 will leave it, keep it as it is. From variables also, we are going to comment. Then tf also will be commenting. Okay, so these files we have commented. Now in main.tf, we can simply do resource. Okay, and I will write AWS S3 bucket, and here also we can just give the name as same, AWS S3 bucket, or S3 module we can give. Okay, this is done. Then in variables we can create a variable, so we'll simply copy the variable from here. This we can use. Okay, simply uncomment it, and just I'm going to remove this description, it is not required. Okay, and outputs we can keep it as output, no need, we can give into the root module. We can just delete this file, ignore. Okay, in main.tf, what is there, how we are defining, we are defining the bucket and ACL. Okay, so simply do bucket, sorry, bucket equal to var dot bucket name, and ACL access control list we can give it as private. Okay, so private like this. Okay, we are good to go. So we have this S3 module now, and now my use case is, suppose I want to create two S3 buckets. So I'm not going to just create like this resource into S3 bucket and copy paste the things. What I'm going to do, I'm going to use the module keyword. Okay, so we are going to use module, and we are going to use S3 underscore bucket one. This is the module name, and inside that you can give the source of your module. So our source is S3 module. Okay, right? S3 module. After that, you can give here the name of the bucket, the variable you can provide, value of that variable. So here you can give my S3 bucket one underscore some random numbers so that it will be unique. Okay, that's nice. And then in the outputs, we can simply print the variables uh, ID of those buckets. So output S3 underscore bucket one. Okay, and value equal to, we can give anything like module dot S3 bucket one, right? Dot anything is, I don't think anything is required. Dot, yeah. Okay, so S3 bucket we can give, I guess, dot the, what is the name of our bucket here? Bucket name, we are given the variable name. Okay, so we can simply keep the bucket name, but why I'm not getting the option? Let's try it like this. Okay, if we get any error, we'll see. Now we can print the output for the bucket 2 also. Okay, module s3 bucket 2, and that I'm going to create. So in main.tf here in our root module, just simply use the module. Okay, s3 bucket 2, and my bucket 2 I can use here, right? Okay, so I guess we are good to go. Yeah, variable something we have here. Let me just clear the screen and go back, and I have to just do Terraform init will do once. Okay, now we will be doing Terraform plan, and here it is showing some error. Let me just check. Okay, for output only we are getting the error. Okay, let me just check. Where is output? We can write like this again: AWS underscore S3 bucket underscore run, and the value equal to modules S3 bucket 2. And in the variables we have this output bucket name. Okay, if we create output file here, output s31 value equal to, what is that in main.tf here? aws3 bucket dot s3 module, right? aws3 bucket dot id. Okay, and in output we can use s31. Okay, sorry, I told you not to use output, but it is required actually. So we'll again create one more output for s3 2. Okay, here also yeah, this is not required. The single output is only we can use, right? Dot s31 only. So instead of s31, I can just change the name here. Bucket underscore id. This I can use. So that will be no confusion for you guys. Okay. So yeah, I guess we are good to go now. Let me just do now plan. It should work now. We will wait. So we can see we have this S3 bucket module name and output we are using S3 bucket S3 module dot id. Okay, plan is done. In variable we are using the bucket name. Then in our root module we are using two times bucket 1 and bucket 2, and we are giving two separate buckets. And let me just clear the screen now. Plan is done. Next step is just apply. Okay. So we should have three resources, two buckets and one EC2 instance. It will take a few seconds of time to create those resources. We'll just wait for it. Okay, it's asking me to add three more similar warnings or not. Yes, and you can see changes to outputs, plan 3 to add is all you can see. Okay, give yes. And you can see instance is getting created, bucket, both buckets, and you can see here module they're using S3 module. And even for your information, it's not like we can use only this internal modules which you're creating. Even we can use the like publicly available modules. So you can find out onto the registry of Terraform website we have there. Okay, and we got an issue. What is the issue? The specified bucket is not valid. What does it mean? Let me just check. Creating an S3 bucket, my SC bucket one operation is response host ID, invalid bucket name. Okay, invalid bucket name it is showing. Where we can add inmain.tf only, right? I guess underscore is not allowed. We'll just remove it. And now we can try. So what is the criteria? I guess special character is not allowed while creating a bucket. So that's why it might have gave us this error. We'll just wait. Okay, Joyous. This error should we should have get in the plan itself. Terraform should do something. Okay, here we can see it is still creating. Okay, EC2 was created, so now it is getting destroyed. Okay, so I guess there was issue with bucket only then, bucket name. Okay, so here you can see model creation is complete. EC2 is getting destroyed, and again it will try to create. Okay, in output we can see the bucket ID and the public IP of the EC2 instance. Okay, EC2 instance is also now creating. So I hope you got the concept how models we can use. So this is an S3 model only. Similar way you can try on your own to create a module of your EC2 instance. Okay, just let us know in the discussion section so that we can help you with that in EC2 if you face any error. Okay, here EC2 instance is still creating. Okay, so here you can see the three resources have been added, and output you can see the bucket one, public IP, bucket two, and the security group ID. Okay, so in this way you can use the Terraform modules to reuse like any resource which you want to be created in your infrastructure. So that's all for this video, and I will see you in the next one. Thank you so much for watching. If you have any questions, please ask us in the discussion section. Hey everyone, welcome back. And in this class, we are going to talk about the Terraform Workspace. Okay, so imagine you are maintaining a project. So in each and every project, there will be some different environments. So suppose you have an environment of dev, staging, and the production environment. So you are doing some changes in the dev environment. Suppose you are creating a VPC, creating EC2, or even S3 bucket, any resource you are creating. Okay, so what will happen by default or not by default, by mistake, what you do, you do the changes into the production environment. Okay, but that you are not supposed to do actually. So in this case, what will happen, whatever your application will be there, that will be break. Okay, or some error or some issue will be coming up. So that's the Terraform workspace comes in a picture. Okay, so I'll just let you know what is the Terraform workspace. So a Terraform workspace is just like a separate state file. Okay, so we have a different state file, so separate state file within same configuration. Okay, so what does it mean basically? So by default, Terraform creates a workspace for you that is a default one. Okay, so whatever we have done till now, all thing we have done into the default workspace. But we can create our own workspaces, like we can create our dev, or we can create the staging, and we can create the production.
three workspaces we can create, and this way the same code can be applied to different environments with different resource name, size, or settings. Okay, so what will be happening? Just for example, suppose we want to create a VPC, okay, and the same VPC you want to create into the dev also, staging also, production also. Okay, so in this way we can use the same code, whatever you have written, and we can change the workspace and we can apply the command. Okay, so just I will show you the help you with the what is the workspace command. So basically, the TF I'm writing as the Terraform and the W is for workspace. So basically, it will be Terraform workspace, and then we have a list command, we have a show command, and then we have like a Terraform workspace. Suppose you have to select any workspace, so you can select dev. Suppose you want to delete, so you can just do delete and dev. Okay, we will talk about this. So okay, in the practical side. So now moving on to the hands-on. So first of all, I'll just show you a bit of code snippet. So basically, that is the basic one. So we'll be creating a bucket itself, okay, into the different workspace environments. So I will show you, just open up your terminal. Okay, let me enter my password. Okay, so we have a VS Code here, and what I'll be doing, I need my terminal. Where can I get it? In devices, where that menu went. Okay, let me just find out that menu. Okay, here I can just go into the new terminal. Okay, so what I'll be doing, so we are at this part Terraform Basics. So here I will create a directory TF workspace lab. Okay, just move into this directory. Okay, and whatever command I told you, that is the Terraform workspace list. Okay, so by default you can see there is a default workspace. Okay, so what I'll be doing, I will be simply creating a main.tf file here. Okay, and what we are going to do, I'm just going to copy this code snippet. Okay, and I'm in the region AP South one. Let me just paste it. So this code will nothing to it to just create a simply S3 bucket into the US East 1 region. You can see. Okay, let me just save it. And I will just quickly show you, as there will be no bucket. Okay, so this is our S3 site. Okay, and there is no buckets actually for now. And let me just go into the US East one. Yeah, here. So in this region there should be no any bucket available. Yeah, there is no bucket. Okay, so what we are going to do now, so I will just creating a Terraform init. I will just type, so it will initialize the Terraform. Okay, then we have different commands to create a new workspace. Okay, it will take a few seconds of time. Till then, I'll just pause the video. Okay, initialization is done. So what we have to do now, we have to create a new uh, workspace. So I showed you workspace before was only default. So I will be creating workspace new dev. Okay, so new workspace has been created, and then here you can see some changes happen in Terraform providers and environments. Okay, and in TF state you can see the dev now. Okay, again I will be creating a different one, so I will be creating staging. Okay, and then I will be creating a prod. So you can see whenever I'm creating a new workspace, so we are just creating and switching to that workspace. Okay, So you can see here you are now on a new empty workspace, and I workspace isolate this state. So if you run Terraform plan, Terraform will not see any existing state for this configuration, right? So just clear the screen, and now I will show you the Terraform workspace list. Sorry, list. So here you can see we have default dev prod staging. Okay, so I will just switch back to the Terraform. We have to select any particular uh, workspace. So what is the command for the Terraform workspace? Select default. Suppose I want to go on the default one. Okay, or I want to go into the dev one first. Okay, cool. So we are on the dev environment. So what I'm going to do, Terraform plan. So let's plan. Let's see what will happen. Okay, so we will create a bucket. So now you can see into the terraform.t. So here you can see the dev. Now in dev nothing is there, in prod nothing is there, in staging nothing is there, right? So now let's apply. Okay, so this will create a bucket for us, and this is the environment variable I'm using for the bucket, that is the terraform.workspace. So it will simply print the workspace, right? So just give a value as yes. So in this case, the bucket will be created as the Ayush dash Teo dash whatever number is there. Okay, so bucket is created. So Terraform workspace show. Okay, so this command will show which we have, which workspace. So dev. So now if I see and just refresh the buckets page, so I should be able to see a bucket there, and I'm not able to see why. So let me just click here, general purpose, and yeah, uh, yeah, actually here you can see I should do 7846. Okay, so now we have created a bucket for the dev environment. Now I want to create a bucket for my staging environment. So I will simply say workspace select staging. Now here also I'm going to use plan. And if you see here for the dev, you have now a separate state file. Now for the staging, you will have a separate state file. So if you do apply now, so you will end up by seeing the separate bucket for the staging environment. Okay. Okay. So if I go back now on my VS Code and just refresh it, so you will see one more bucket there. Okay. So staging you can see. In the similar way, we can create for the prod, and that's your task to create for the prod. Okay. So now, what's next? So the next thing is we'll be simply deleting or cleaning up. So just to terraform destroy. I don't want my bucket to be there. Destroy. Okay. And to delete a workspace, so we have a command terraform workspace delete and the workspace name. So in this way you can. So here you have to just type yes. Cool. So now, what if you are on the same workspace like Terraform workspace? So workspace. Okay, what happened? Yeah. So staging. So I can't delete from the same workspace, the same workspace which I'm using. Like staging, I can't delete from this staging. So I need to switch back to some different. So if I switch back to the Terraform workspace. Select dev. Okay, so now I am on the dev. So I want to just delete the staging. So we're doing delete staging. So in this way, you can just delete your workspace. So I want to delete the prod also. And then I want to switch back to the default. Sorry. I'll be selecting dev. Okay, already I'm on dev. So first I will destroy. Terraform destroy. So our bucket will get deleted. And then I will switch back to the default and will delete this workspace. Okay. So if you don't want to enter this, yes, you can use like hyphen auto approve. It will work. And now I want to switch back to default. Select default. Okay, let's delete the dev one. Let's try hyphen auto approve. Okay, no, it's not working. Okay, so dev is also deleted. If I just do list workspace list, so now I will end up having a simple default workspace. Okay, so yeah, that's we have. So that's it for this video, and I will see you in the next one. I hope you got it. If you have any questions, please ask us in the comment section. So thank you so much for watching, and I will meet you in the next one. Thank you. Hey everyone, welcome back. And in this class, we're going to talk about Terraform provisioners. Okay. So what are Terraform provisioners? So we'll go through the quick introduction of this. So as we are aware, like Terraform job is to just provision the infrastructure, which means like building the infrastructure. Like we can create EC2, S3, we can create Lambda functions, we can create VPCs, so many things. Okay, but what if we want to run some commands as well? Some if, for example, if we are set up, we are doing setup of EC2, and we want to simultaneously run some scripts. Like we can try to install a web server, we can try to install app servers, something like that. Okay, so in these cases, Terraform provisions comes into the picture. So what it helps, so Terraform provision allow you to execute commands. Okay, so basically it used to execute commands, and where it can execute on your first local machine also and a remote also. Okay, where you will be deploying your things or whatever infrastructure you're trying to create. Okay, so I think we are clear with the provisions. So we have two different types of provisioners also. Okay, so what are the two different types? That is the first is local execution. Okay, so it is used to run commands locally. Okay, then second one we have, as you might have guessed, that is the remote. Okay, remote execution that is used to run command on the remote resources. Okay, using SSH. Okay, so these are two different types, and also one more thing I will tell you, like provisions we use it, we can use it for our like small purposes, like just to you or some testing you are doing or so, yeah. But it is not recommended to use into the production environment as like provisioners. We have some other tools also, like third-party tools, just like the we have Ansible. Okay, I guess we have Puppet, we have Chef. These are the configuration management tools. Okay, so these tools also we can use, we can integrate with the Terraform, and we can do whatever operation we want to do. Okay, so we'll go through the demo now. So this was the overall theory, and I hope you got it. So let me just open up my VS Code. Now what I'm going to do, I'll be simply creating a different directory. So mkdir Terraform, I can write as provisioners. Okay, so just to cd Terraform provisioner. And also we just if you don't get confused, I can open up actually new one. Where it is, Terraform basics. Okay, Terraform provisions I can open, right? Okay, cool. So here we will simply create one file, that is main.tf. Let me just close it. Another one, if other is also there any. Okay, only one we have. Okay, so I had to copy some. Okay, we can folder. Okay, this main.tf we have, that I wanted to copy just. Okay, and you also just create a new directory and you can just do it. Okay, I'll just paste it here. So what this will do, it will be going to basically create a S3 bucket in your US East 1 region in your AWS account. Okay, now I'm going to show you the simple thing, that is a local execution. Suppose I want to create some txt file, okay, after creating this bucket. So what you can do, you can just simply type resource. You can give the type of the resource or like null resource, okay. Then you can give any name like local, okay. Then inside this block you have to write the provisioner. Sorry, I wrote provider. Provisioner, and what are the different types? So I have this local execution. Then in local execution I will be writing some command. So you have to give command equal to, and the command I will be giving just echo s3 bucket, and bucket name also we can write as dollar this, and we can write this aws underscore s3 underscore bucket, and then dot again dot this dot bucket. It will give me the bucket name, and then we can just append the output of this into a new file. Append bucket.txt. Okay, cool. So this is the local execution. So you can use this format to write any local command. So let's just open up a new terminal. So we'll be doing Terraform init. So we'll wait. Okay, it's done. We are going to simply do Terraform plan. Okay, plan is also done. And then what we have, we are going to do simply Terraform apply. So this will create a txt file. Yes, I want to keep yes. Just wait for a few seconds. Okay, so creation complete, and here also you can see the file name as the bucket.txt, and we got the file name, and you saw here that this command has been executed echo. Okay, you can execute any other command also which you want. So in this way we use the local execution. So that is for this class, and in the next video we will see the remote execution. Thank you so much for watching. Hey, in this class we are going to talk about the different type of provision that we are going to do, that is the remote execution. Okay, so basically what we're going to do into this, so we'll be creating a EC2 instance. Okay, so what are the prerequisites that is required for us to do? So first of all, you should have a key pair. Okay, so that will be used to connect to your EC2 instance through Terraform using the SSH. Okay, Next, we need a security group as well. And the third thing which we are going to do, like into the EC2 instance, we are going to install the Apache. Okay. So this thing is the important one. Like here, we are going to use the provisional block. Okay. With remote execution and with inline. So in inline, we can write the commands one by one. And also we have some different things like scripts that will refer to your local script that you can provide. Okay. So this is the overall topic will be covered in today's class. So first of all, I have my actually source for the Terraform security group on the Google, and I got the result that's quite good one. So we'll simply copy this one, okay, and we can create a security group as well. And I will just open up the AWS console. I will just show you how you can create a key pair. So you have to just go into the instances. So that is, you have to search for the EC2, or if you are recently visited, you can click there. And then we have this key pair. So just click on it, key pair. So already I have created one key pair that you can see here is the TF provision remote. Okay, you have to simply copy into your wherever you are running. Like I'm reusing the Linux Mint, so I have copied already there. So to create a new key pair, just click on it, give the name, give the type as the .pems. So that will be used for OpenSSH connection and simply create key pair. Okay, so already I've done, so I'm not going to do it. So just go back and I will open up my VM. So just wait. Okay, so VM is finally up, and here you can see this .pem file already I have copied here. So just do Control Alt T and do code. Okay, we can open a folder, and in Terraform Basics we have provisioner. Okay, here we can create a new folder that is the Terraform remote. Create. I will open this. Then I'm going to create a main.tf file. Main.tf. Okay. I'll just open up a new code also. New base code. I have to simply copy that provider and all. So just open a folder and in Terraform Basics. Provision is this only I want. Is main.tf. Okay. So this thing we can copy, right? Okay. Done. Just close it, paste it, done. And already we have this one, security group, that also we can copy. And also here also I have the same code actually. Okay, so we are going to use this only. So you can see the resource block in the security group, then we can give the name, and this is the VPC ID for me. That is the this is the default VPC ID. You can get your VPC ID on from your console. You have to just simply search for the VPC, click on it, and it will show you the list of VPC which you have. Currently, I have only one VPC, that is the default one. For you, also one if you have not created any VPC yet. So just do your VPCs here, and it will show you this VPC ID here. You can see. So this is the VPC ID, same you can see here also. Okay. So 07UB71, okay, whatever it is. Okay. Then in the security group, we have two ingress rule, that is two inbound rules we have, that is the port 80. So what we are going to do basically, security group will act as your firewall, you can say. So that will allow port 80 and 20. 80 will be used for the HTTPD, which we are going to install, that is the Apache, and 22, sorry, not 20, that will be used for the SSH connection. Okay, and the output bound, like it is like we can browse anywhere and it can connect to any IP and it can go. Okay, so that is your egress here. Okay, and same resource block we have instance, so that will come up on there. So first of all, copy this part. Okay, so let's go ahead. Okay, I already have copied, that's fine. Okay, so your security group is done. Next you have resource, and we can give the AWS underscore instance, right? And the instance name, what I want to give, what was there, we can give the same web. Okay, and this AMI I'm going to use this line. I can copy. Okay, web is done. Then this is the AMI resource which we are going to use here actually. So AMI you can get from your previous whatever previous videos where we have created instances. Okay, why it is not getting copied? Okay, that's why I'll write simply AMI equal to here. If I go, I'll just copy this. It's not getting copied. I'm not sure why. If I do like this, Control C. Okay, now in clipboard it's going fine. Main game now. These are the backticks. Okay, AMI we are done. Then we have the instance type that we can give as the t2 dot micro. After that, we have this is key name. So the same key name we can provide in the security group also. So wow, I don't know what is happening with my control C actually. Doesn't want me to copy links. Okay, just paste it. Key name is done, security groups are done, so we are going to use the same security group. And the important thing now it comes at is the provisioner block. Okay, so we are going to write this provisioner, and the type we have the remote execution. After that, what we have to do, we have to use the inline. Okay, so you can see the inline here. We are going to write all these uh, commands which we will going to install your HTTPD. Okay, I can remove this. I can remove. Okay, inline is done. Then we have this connection block. So that is the type. You can see the SSH, and also you can see the host. So that also we can write here after this connection. Then we can give the type as SSH. After that, what we have to give, then we have to give a user. So user we have the easy to user by default. So the user will be user equal to EC2 user, and then we have a private key. So private key we can give using the file, and I didn't copy private key here. Let me just copy it. Control C, and here I can do Control V, paste. Cool. Okay, so open up a terminal. I will just copy the whole path. So pwd, Control Shift C, and then slash. We have this df dash provisioner dash mode dot pen. Okay, then we have to provide the host. It will be after this host equal to self dot public. Okay, cool. And I will tell you though what is the mistake which I was doing. So the mistake which I was doing basically here, the resource name, resource key name. Here also giving the same file location. So here you have to basically provide only the name of the key which you are going to use. Okay, so that's it. Let's quickly do the Terraform init. It will take a few seconds of time to initialize, then we'll do plan and apply. So we can see like we will have a running HTTPD service. Okay, so plan is not done, init is done. So to do quickly, Terraform plan. It also a few seconds of time. And the VPC main ID we must. Okay, so here I have to copy the VPC ID. So what was the VPC ID? Here we have. It's better to copy from here. Okay, let's do plan again. Hmm. And why it's okay, your IP address. I'm doing mistakes, too many mistakes today. So IP address will be 0.0, so it will be accept the traffic from anywhere. That's why. Now the plan. I guess now everything is fine. Yes. Plan is done. Two resources getting added, one security group and one the EC2 instance. Let's clear the screen, do the Terraform apply, and it will give you the instances. So let's quickly open up not this one. Do yes. What I opened here. Shit. Okay. Just do yes. We got error. Why we got error? It should not creating security group. Invalid VPC ID. VPC doesn't exist. Wow. Why it is that is the where is my the where the other code went? That US East one provider block. Wow, I replaced everything. Let me just copy it again, guys. Okay, now apply. So in US East one, inconsistent. Okay, let's do a plan. Okay, inconsistency, dependency. Going to delete everything. So all we are going to do from the fresh. Why it is not deleting here everything? One is only pending. Yes. No. Do ls-ltr, ls-altr. Then you have to do rm-rf dot terraform. You're good to go now. Do terraform init now again. So you can see I missed this the whole block, the main thing only. Provider block itself I missed. Just wait. Initialization is done. Let's do Terraform plan. Now it should work. Now to Terraform apply. Okay, it will ask okay to yes. Security group is creating. Yes, already security group. I have that one. It's going EC2. So it is creating the security group ID. Okay, creation is complete. Now instance it is going to create. Still creating. Go in instances. So one instance is running. It is showing. Okay, okay, that is initializing. That is fine. Public IP you can see the 54175. Okay, so here you can see the remote execution block is running. And the IP, you can see the same, this one 54175162550. Cool. Okay, one instance is getting created, then we can see at port 80 we will have this running HTTPD, okay? And also this HashiCorp suggests like you should never use remote execution until and unless you don't have any other option. So any other option like you can have you can use this Ansible, Puppet, these things. Okay, we are done here. Uh, Since created initialization, it should be done. I can copy this public IP and I can open up into the new tab, paste it, and something should come like it works. If everything is fine, it should work. Yeah, okay, it works. So here you can see, like we have finally successfully used the remote execution to install this HTTPD. So in this way, you can use the remote execution. That's it guys for this video and I will see you in the next one and just for your task. So using the remote execution what you do, you create a new file into the EC2 instance. So that will be very helpful for you and you will learn how you can create a new file. You need to write a script or something which you want to use. So that's it for this class and I will see you in the next one. So just do Terraform destroy so to save the cost. Okay. Thank you so much. Bye bye. Hey everyone, welcome back. And in this class, we are going to talk about a different provision that is the file provision. Okay, so it is also a very simple one. So this is used to basically copy the files from your local machine. So this is your local, and you're going to copy into the your EC2 instance or the VM. Okay, so provisional file type provision will be used for this thing. So basically for this class, what the hands-on we are going to do. So in our previous class, we have installed the HTTPD using the remote provisioner. So remote execution provisioner. So what we are going to do, we are going to simply copy our index.html file. Okay, at this position, this will be the directory HTML. Okay, and the only issue which we have is that this is with some root user. We can keep files with root user or the Apache, I guess. Okay, but we are using for the connection the EC2 user, right? So to just solve this issue, what we are going to do, we will be giving this as a chmod 777. So any user group or others can do read write execute permission on this particular directories. Okay, in this directory basically. So let's quickly do it. So already we have the code of remote execution. We can use the same. So what we are going to do basically. So this is my remote code and I will be basically creating a new directory and we can do mkdir terraform file then cp main.tf dot terraform file, that's it, then terraform. Okay, it didn't create, I guess. Okay, it created. Cool. Terraform file we have and it didn't copy, no issues. We are going to copy the remote VP main.tf Terraform file. What happened? Copy is done. Okay. Cool. Let me just open up a new file window and this will be the folder. Go back and do file. Okay, what I did actually. Okay, I should have opened folder, right? Terraform file open, done. Okay. So this is the main.tf file. We have everything here. We have provision remote execution. And one more thing, if you are going to use two more provisioners in your in your TF file, then in that case we can use a single resource block. We can keep it outside also, and that is purely fine. Okay. So remote execution is done. So after that, the main first thing which we have to give is the permission. So sudo chmod 777. We are going to give the permission to the directory HTML. Cool. After that, simply we are going to use the provision block. So that will be with the type of file. And here it accepts two things, that is the source. So you have to basically provide the total. I mean, it's absolute path of your file which you want to copy. So pwd करेंगे, then we'll do pwd, we'll do control shift C. After that, paste it, and the index.html we have. So we are going to create basically, and then we will keep the destination as the same, which we have written above. HTML, yeah, that's nice, and yeah, that's it. So first, let's create index.html. So here just do a shift one. This exclamation will come, and then you can write anything which you want. So here I will be simply writing please complete all the tutorials. Okay, cool. Let's clear the screen. Let's initialize, and it will take a few seconds of time. So I'll just pause the video till that time. Okay, this is done. Next we can go for the plan. It will also take a few seconds of time. Then we can do the Terraform apply. It will create the two resources. What are the two resources? It will create the security group and EC2 instance, and then it will copy our index.html file. Then we can see the changes. Okay. So till that, I'll just pause the video. It will take a few minutes of time to complete. So okay, and just now I realized we made a mistake. We had to give here the name of the file also. Okay, no issues. Once it is done, we can again destroy and we can create. So it's still creating. Okay, it's created actually. You can see this IP, and if I go on this IP, it's showing it works only. It is not showing the our change index.html because we have to give the name of the file here as well. So no issues. I will try to simply do Terraform apply. If we do whether it will work, let's check. Refreshing straight, instance refreshing. Whether it will copy. Okay, it will destroy and it will again create. Okay, let's wait. I will just pause the video. Okay, so provisioning with file is also completed. So now it should be successful now. Let me just copy the IP and we can check where it is went. Okay, so this is the IP. Just copy it. And it should come, please complete. Yeah, so you can see please complete all the tutorials is coming up here. So in this way you can use the provision. Just to verify what we can do, I'm going to just go into the another directory, that is remote one, because here I have that PEM file. So I'll just log in sh-a tf provision.pem ec2 user at the rate IP. Okay, we can do yes. And I will go at the same path which I gave here, that is var www HTML. So currently I'm into this HTML. If I do OMI, it will give me the EC2 user. If I do ls, so here it will show me the index.html, and if I do cat here, so I will get the same file which we uploaded. Okay, so this is the way of using the file provisioner. So just go back onto your file one and just apply the Terraform destroy to save the cost. So that's it guys for this video, and I will see you in the next one. Thank you so much for watching. Hello and welcome back, and in this class we are going to talk about Terraform functions. Okay, so imagine you want to create any resource and you want to give the name of the resource dynamically. You don't want to just hardcode the value. So in that case, you can use the Terraform functions, and these functions are similar like the functions which we use in different programming languages. Like we use the upper function to just make the string in uppercase. Then we have the lower function. Okay, then we have the min, max. These functions we have also, and also with Terraform, we can use the function for the list also, map also, okay? So these are all the functions I'm going to show you in this class. So let's go the hands dirty. So let me just open up the code. Okay, VS Code, and we'll start with the basic. So let me just open a folder and I will go in Terraform Basics. Here I'll create a folder with name Terraform Functions. Okay, as soon as I've written just for shortcut, create a file main.tf, tdf, tf. Okay, so the first few functions that will be related to the string function. So it will be we can write as output and give any name like string example. After that, we can give the value. The value we can give anything, and the upper we can give the upper function to just write anything. Terraform basics. Then we have output function. We will give it to do string example2. Output we can give like lower we have. I don't think we have. Okay, we have, yeah. I'm giving output. We have to give value here. Lower and ABC. Okay, we'll try with this one. Okay, Terraform string related to the string functions. So just open up your terminal and same the three magical commands which we have: Terraform init, Terraform plan, and then Terraform apply. So here you can see string example, Terraform basics, all are caps. Then we have the lower with the related to with lowercase letters like ABC. Here you can see. So in this way, you can use this upper and lower in whenever you're defining any bucket. So in their name which you want to provide as upper and lower case, then in that case you can use. And also the important one, that is the I will show you just now, that is the concat one. So you can concatenate also some values. Suppose you have to concatenate values of region and workspace. So that also you can use. So that will be defined with using the join keyword. Okay. So for join, it takes up two things. The first thing you can see as a separator, and then you can define the list which you are going to join. So separator, I want to give us suppose a hyphen, and suppose here I am giving the US East one, uh, and that will be into the list actually. So how we define the list we will define into the big brackets. Okay. So US to East one, here we can see the dev workspace. We can write dev work space. Okay. So now if I do Terraform apply, so here you can see it will give me the US East one dev and dev workspace. Okay. So in these two you can see the hyphen we have. If I add anything else also here, that will be also like one dash will be added before it. So here you can see workspace test. Okay. So in this way, you can use the join keyword in which the first parameter will be your separator and the next parameter will be the list. In this way, you can use the join keyword. Now, moving forward, we can use the in a variable way you can define any kind of list. Okay, suppose you want to define a list and you want to access that list. How you will be doing? So we are defining a variable with the name of a list of, or just to give the instances. And here, suppose you want to provide default, and that will be like T2 micro. Then here you can see the comma T3 dot micro, then C6G. Okay, so this is the variable, and output you want to give as the instance name. Okay, and value you can provide. And for this, to access the list element, to access the list, we use the element which will accept the first parameter as the list and then the index number. So just do the element and the list we have the instances here. So that we can give as the var dot instances, comma, and the whatever index you want to do, you want to fetch. So if you have learned any programming language, obviously you might have learned. So indexes starts with 0, so here will be the 0 will be this, 1, 2. And even if you give 3, so it will go like this. 3 will be this, 4 will be this, 5 will be. Then if I give 6, 6 will be this. I'll just show you with 0 first and give yes. Okay. And if I give 6 here, then also you will see I will get the same output of T2 micro. So here you can see for 6 also T2 micro. If I can be given, if I give 7, that will be T3. Okay, so in this way you can use the indexes to access the element from the list. Now next we have map. So map also we can create a variable with name AMIs, and here we can define the value. Suppose the map is stored in the key value pair. So suppose in US East 1 we have AMI of 1, 2, 3. Then we have US East 2 if I give equal to AMI 1, 2, suppose like this. Okay. So in this variable we are storing the like in the key value pair. Now if you want to access the value of these key from the map, so we use lookup actually in values. Then if you do lookup here, so if I just show you, if I type in lookups, so here you can see you can give the input map, the map we have, and then the key as a string. So lookup is done, and the var.ami, this is my map, and the key I'm going to provide as the US East 1. Save it, do it, apply, give yes. And here you can see the AMI 123. If I give US East 2, so in that case, it will be AMI to 123. So US is 3, that we don't have. Okay, 4, so it should give an error. Okay, so in this way, you can use the map. Cool. Next, we have numeric we can use. So numeric, that is nothing but min max. So min number we can use the name. Value will be the if I give the min, and if I pass some numbers 5, 10, 3, so I should get the min. And if I do max number and pass here value equal to max of 1, 2, 3, just hit a apply button, give a yes. So in this way you can see the max number is 3, min number is 3. Okay, both are same. If I do 1 here, so I should get the min for min 1. Okay, min number is 1, 3. Okay, so in this way we can use this functions. Okay, and for you the task is to basically create a S3 bucket. Okay, create a S3 bucket, and the name of the bucket should be into the upper letter. Okay, and also what you have to do, you have to use your workspace name, and all should be into this like separator. For this should be a hyphen. So just give write in the comment section how you are going to do this. Okay. So that's it guys for this class, and I will see you in the next one. Thank you so much for watching. Hey everyone, welcome back, and in this class we are going to talk about dynamic blocks. So today's class is on this topic itself, so we'll discuss on this. So sometimes in Terraform you need to repeat similar nested blocks inside a resource. Okay, for example, a security group which we created in our last class, in which we see suppose we had to provide access for the 80 and 22 inbound access. So we copied these two like blocks of ingress, right? So these two blocks we copied two times. So this is a repetition of things. So, but we don't want to do it. Suppose you want to give access to the 10 ports or 100 ports. So you are not going to just copy the same ingress things again and again and again. So this is a problem which dynamic blocks solve. So you might have heard about the thing called loops in a programming languages in any programming language. So same similar concept is going to apply here also, but that will be applied with the help of the dynamic blocks. Okay. So how we are going to do it? The very like the best example I'll give you with the help of like security group itself. So suppose we'll create a list. Okay. So we have a list, and in this we can give the port numbers, right? And we'll be using the dynamic keyword. So this is a dynamic keyword, and there will be the ingress. And under that, we are going to define a for each, and in that we are going to use the list variable. So this is suppose L, so just L, and then we will be providing the content, and inside that we can provide the whatever we provide the ports. We will be taking the each value, and if you see the security group, so in security group in the inbound rules we will have all these three ports enabled. Okay, so how we can do it? So already we have done in our previous classes, so we have to simply just copy and paste the code. Just will be change that particular block. Okay, and we'll be only creating the security group. So if you see here, let me just create a new one. Terraform basics. So here we can create a function, sorry, folder with the name Terraform dynamic blocks. Okay, open it. You can use main.tf here. And already now in our previous class we have used this one. So I'm just going to copy it and I'm going to paste it here itself. Okay. I don't want to create a instance, so I'll just remove the below code as it will save our time also. Okay, so here you can see we are using port 80 and 22 ingress, and egress is 0. So we are using two ports here, but what if we want to give 10 ports or 50 ports? So we are then again if we are doing manually, we need to copy this that much number of time, that is a 50 times. So instead of this, what we are going to do, we will be creating a list. So that you can create using the variable. Just give the name ingress ports, and then the value you can give default. That is the suppose I give 22, 80, 443, even 23 I want. Okay, so for I am going to provide access for my security group, and then what I'm going to do, just remove this, and I'm going to use a block of dynamic. So to give dynamic and give the ingress, then you are going to provide the for each loop. In that you can provide the var.ingress ports here you can see. And then we have the content, and inside this content we are going to pass these values. Just remove this block, and here you can use the ingress dot value, right? Similar here also you can use the same thing, ingress dot value. Okay, so from port, it will pick each port one by one, and it will create a security group for us. So next we can use the three commands as you already know: init, plan, and apply. So let's do a Terraform init. It will take a few seconds of time. Okay, it is done. Now we can go for Terraform plan. Okay, plan is done. Let's do Terraform apply. So here you can see currently my security groups. So we have to give the value as yes. Still loading. Okay, so currently we have 4 security groups only. Okay, now it is showing created. So if I just reload it, one more should come. Okay, this one you can see example Azure. If I open it, so here you can see my inbound, all the inbound ports 22, 23, 84, 43. So all these created just using the one single code block. Okay, so now you know about the dynamic blocks. So the task for you will be to, when you will be creating an EC2 instance, so there you provide the tags, right? Similar here, I have provided the tags. So for EC2 instance, you have to provide the tags, but using the dynamic blocks. So you have to provide at least 5 tags. So you can just create a list and use the dynamic block. Okay. So that's it for this class, and I will see you in the next one. Thank you so much for watching. Hey everyone, welcome back, and in this class we are going to learn about Terraform remote state. Okay, so as you guys already aware of the local state, like this you do every day. So whenever in our previous classes we have initialized the Terraform, so that state file gets created, and in that state file it maintains the memory of your Terraform, like what resources has been created and what resources has been deleted. So this thing we are already aware, and we have a lecture on this also. So we will see why you should not use local state, not locate, okay, local state. Why you should not use. Then we will be doing a setup of S3 and DynamoDB. Okay, we will see how this both will help us to do the remote state. Okay, we will be managing this state file remotely. And then nothing, just hands-on only we are going to do. Okay, so let's begin. So for this class, what we have to do, the first thing we will be doing, that is we'll be creating a S3 bucket, and then we are going to create a DynamoDB. Okay, before that I'll just let you know the flow, how it works, basically that remote state. So suppose there are, if you're a single person and you're working on your personal project, then in that case, your local state file is quite good. You don't need to use this S3 bucket and DynamoDB, as no one else is going to use your Terraform state file other than you. But if you are in a team, okay, in a team of some person, some few people, like 4 5 people, or two person even. So suppose person A is there, person B is there, and this is your server. Okay, you are using this server, and in this server you are also creating a Terraform resource file, any bucket you are creating, and this guy also is creating in the same directory if you are. So in that case, what will happen, both people are going to change the state file. Okay, tf state file. So in that case, your state file will get corrupted if both are using at the same time. So this is the issue if you are working in a team. So to solve this issue, what is the solution we have? That is, the we'll be storing the state file in the S3 bucket. Okay, so here you will have the S3 bucket. Okay, in that bucket we are going to uh, keep our state file. Okay, state file we will be having, and then we will having a DynamoDB. In that we are going to insert one row. okay, with a key. So what will happen if we take the above scenario like A, B, so this is the A, this is the B. So this guy is suppose doing Terraform apply. So in that case, what will happen? This will go and do the changes in the state file and create one entry into the DynamoDB. Okay. In the DynamoDB, it will create an entry with a key, suppose with name key1. And in case if person B is also going and trying to insert in this case, so in that case, usually if you have a primary key, so what will happen? It will throw you a unique constant error, but in case of DynamoDB, it will show like resources already used or something like that. Okay, one error this guy will fish, and in that case, your it will show like it will be the concept of like log DB. Okay, log DB or key, I guess log to DB. Okay, so in this way, we can prevent the conflicts. So we are going to do the hands-on. So first of all, we'll be creating a S3 bucket actually. So let me just go to the S3. Here you can, you need to, what we say, give a unique name. So general purpose only I need, so I can give my Terraform log dash 6547. And you have to block this. Okay, then you need to enable versioning in case if your state file gets deleted so you can recover, and just create a bucket. So we are in the US East one only. So bucket has been created. Okay, next we have to create a DynamoDB. So just you have to do click on create table and give a table name something like Terraform remote table. Okay, you have to give a partition key. You can give the name anything which you want. So I can give the name as something like we can give what we can give key, or okay, like ID we can give lock ID. Okay, short key is not required. So partition key is just acts as your primary key. So you can read here also partition key is part of the table's primary key, and if you do short key, it will act as the composite key. That's it. If you understand relational database, then you can easily understand this thing. Okay, so this is the default settings only, and what we can do, resource based policy. Okay, we can keep it all as default. Now just to create table. Okay, so it will take a few seconds of time. Okay, well, I'll just pause the video until it's created. Okay, so here I can see table is created. So if I just click here, so I can see nothing is there. Okay, get live item count. If I see, okay, nothing is there. Explore items you have, nothing we have. We can create any item we want. So whenever we will do apply, so one item will be created here. Okay, so what we have to do now, the next step will be, so in your whatever Terraform file, we are going to have a block of backend. Okay,
backend S3, and that will be under Terraform. We will be creating a file with backend.tf. Inside that, we will be providing the whatever the configuration details, like bucket name we are going to provide. I will show you how. Then key is there. Don't get confused this key as the DynamoDB key. It will be the path of your S3 bucket where you want to store the file. Then we will have the region. So US East one obviously in this one. Then dynamo db underscore table. Here the name. Then what we have, we can give the one option of encrypt. So it will just encrypt your state file, like server-side encryption will happen. Okay, so let me just open up my terminal. Okay, so here we can take any our previous TF files. So I'm thinking to take a file of our we can take of EC2 one. So let me just search where we have created Terraform provisioner is there, dynamic blocks. We have functions. Is it a function? This one we can take remote, right? There main.tf file I have. Mm, okay, so what I will be doing, I will just copy this full directory itself. cp-r terraform remote with the name terraform state. Okay, cool. Now I will just open up that folder from here. That will be this one. Let's quickly open it. Okay, so I'm going to simply delete this one. That we can do it from the terminal itself, no need to do from there. Okay, we are in Terraform state. We are going to do rm-rf dot terraform. Okay, then give star, it will delete everything. Okay, then we have Terraform state file also, that also it will remove. Okay, cool. So now we have only this main.tf and that index.html is also there. I guess we are copying it somewhere. We are copying or not file. Maybe it was used in file provisioning. Okay, we are not copying here, so we can simply remove this not required. Okay. So now we have this main.tf. Now we are going to create another directory that is the backend.tf. Okay, insert whatever I told you to add, the same thing which we are going to add. So the block will be Terraform. Then we are going to have the backend. We'll give the S3, and inside S3 we can give the details. Okay, so what will be details we discuss? So details will be our bucket. So just give the bucket equal to what is the value of the bucket. So we need to check from here. So I'll simply see the bucket name and copy paste. This one we can see my Terraform log something. Okay, this is the bucket. The next thing which we are going to give, that is the key. So we can give as where we are going to store. So we can give as dev slash something. We can give dev slash terraform.tf state only. Okay, next we have the region, so that we are using as US East one only. What is the main.tf? It should be same. Yeah, US East one. Then we have the Dynamo table. So Dynamo table name is what it is. Let me just check the name of the table. Terraform dash remote table. Okay, and the last option which we have, that is the encrypt. We can give it as true. Okay, just save it, and now we are good to do Terraform init. Okay, so it will initialize the backend, and it will go to create a state file. We can see if anything came here. Okay, no object yet. We'll just wait few seconds. As locally init is faster, but for S3 it will be a bit slow, as there is a network communication. Okay, let me just check. Okay, we are not able to see anything here yet. We'll just do Terraform. Sorry, we had to do plan actually. Okay, so we got something. Okay, we are going for acquiring state log. This will take a few moments. Acquiring the state log, operation error. 400 request ID, one or more parameter values were invalid, missing key lock ID in the item, unable to retrieve item from DynamoDB table. Okay, the provided key element does not match the schema. Okay, Terraform requires a state. Okay, we'll see what is this issue. Okay, so I checked the issue. So the issue is related to our the DynamoDB table key. So Terraform looks for the case sensitive key, but we gave the key as the uh, lock ID. It should be lock I and D, both should be capital. We'll see if we can update anything. Mm, Indexes we don't have. Accents, create item, edit. Okay, nothing is coming up here. Go in tables. Just delete this table and I'll just recreate. Just Control C. Do confirm. So we should always give the key as a case sensitive. Okay. So create table. Dynamo DB. So log ID is there. We have to give capital D. Now everything is correct. To create table, it will take a few seconds. Again, we'll just do app plan. So now it should work. So it will take a few seconds. Okay, it's created. Now again, we'll just go and clear the screen and do it again. So now we should not face any issue. Okay, acquiring the state. We can see if anything is here. Okay, so here you can see it's showing plan is done. So now there will be no items will be there actually. So once apply is done, so it will simply delete the key. So explore items, and in history bucket also I will see if anything is there. Okay, nothing came yet. So we are going to just do apply. Terraform apply. So it will go and create instances. So till then we'll just wait. We have to do yes as always. So just a pause for a few seconds, and I'm getting some error. Okay, security group already exist. Why we didn't delete? Here also you can see, okay, that's fine. Deleting state log is happening. Okay, okay. So here you can see now the state file has been created dev. Okay, here we can see the state file also. So when we did apply, so in that case we got the state file. And what we can do, we can just change the security group name for now, and then again we'll do apply. So that here you can see acquiring the state log. And one more thing I can do here. Here also I'm going to just apply Terraform apply. We'll see what happens. As at two places, same thing is going to happen if I do yes here. And now here if I see, so you can see it got an error requiring the state lock. So in this case, it can like you can prevent the conflict of state file in your team. So in this way, you can use the DynamoDB and the S3, and I hope you understood how in the background this is working. So this is all the thing of that key which we created in the DynamoDB. So that is the only the main thing. So whenever we are applying, it is creating a key, and then whenever it is completed, that key is getting deleted. Actually, my system is slow. Otherwise, we could have see if we do tables. Explore items. Okay, so here you can see the keys actually. This ID is there, operation, right? So I'll just refresh it. Two is there. Here is still it's creating. So once it is completed, then we will see only one should be there. Other one is I guess from the another terminal. Okay, only one is there now. I guess this is completed. Okay. So in this way you can see how Terraform with remote stay with S3 and DynamoDB is working. So now it's time to just destroy to save cost. So that's it guys for this video, and I will see you in the next one. Thank you so much for watching. Hello, welcome back, and in this class we are going to learn about the Terraform state manipulation commands. Okay, that is the TSM basically. So, so far we have seen like Terraform has been managing state for us like automatically, right? But sometimes in some cases we have to and we need to directly interact with the state file. Okay. So whatever the state file is created in which Terraform remembers what resource it has created and what resource it has deleted. So that is the state file which we have already discussed on this. So if we want to directly interact with the state file, sometimes to just inspect, to move or remove any resources. So in those cases, this Terraform manipulation commands comes in the picture. So I will just let you know like why it is important, like why state manipulation. Okay, why we need it. So basically, here are some situations like suppose the first one like you renamed a resource in code but don't want to recreate it. Like suppose you have created a resource with like my bucket, okay, and then later in your project you want to make it as dev bucket. So in that case, you don't want to again just destroy the resource and again trying to create with this resource name. Okay. I'm not talking about the bucket name, I'm talking about the resource name. Okay, so whatever you give the name in the after resource and the name which you give it here under this at this place, so that name I'm talking about. Okay, so second case it could be like suppose you have imported an existing resources, okay, and you want to just reorganize it, and also if you want to inspect the attributes of any resource, so just to inspect attributes like what are the things are there and the info of that resource. So in that cases we can use this manipulation command. So I'll just let you know these are few only, four commands only. The first one is the Terraform. I'll just like TF, okay, Terraform state list. It will show all the resources which are uh, present in the state file. So I will just show you here. We will just do the practical also. Let me just open a folder and Terraform basics we have. I will just create a new folder with the name Terraform state manipulation commands. That folder is located. Just open it up. And in this, nothing we are going to do. Already, which we have this snippet. I'm just going to copy it and just paste it. Create a new file with the name main.tf. Just paste it. Cool. Now what I don't want to create any instance here. Okay, so I'll just remove this as it will take time to create that. So I'm just removing it. Instead of that, I'm just creating another resource with the name of bucket, like my bucket. Okay, and then just give the bucket name as anything. Bucket equal to hello world 789.456.123. Okay, so now just open up a terminal and initialize the project. Terraform init. Okay, so till then I'll just let you know the other commands which we have. So the first one is the Terraform state list. Second one we have like Terraform state show. So we are going to write Terraform state. I don't know, my piece is hanging, that's why this is happening. Okay, it's just Terraform state so, and then the third one which we have, that is the, it will be Terraform state remove, and then next we have Terraform state MB, just to rename any resource. Okay, so if I try to write again, so second one was the Terraform state show and then the name of the resource. Third one was the Terraform state MV, just to rename the old one name, then new name, and fourth one will be the Terraform RM, and then the same resource name. Okay, so Terraform state actually. Okay, so that will be removing your uh, in resource, but it won't remove resource from your, what we say, from your actual resource. It will just remove from the state file. And here we got some error. Actually, what is the error? All modules should specify the required for the external consumer will get the correct providers. Okay. Terraform required provider we have, provider AWS we have. Okay. Here we have to give, I guess, AWS S3 bucket. I did a mistake. We did. Okay, save it. Here I'm just given the name. Okay. Now again initialize. It will take a few seconds of time. Okay, it's done. Next to the command we will type as the Terraform plan, and then we'll just apply. It will create two resources for us. One is the bucket, another is security group. So let's do apply. Then we will have a state file. Then I can show you all the commands which I just told you. Okay, bucket name. It is bucket is creating with this resource. That name, actual name is this hello world. Okay, So now we have the state file. Let me just clear the screen and now I will show you the Terraform state show. Sorry, state list. So here you can see the two resources which we created, that is the S3 bucket with it is coming with this name, and then we have the security group, example security group. Now the next command is if we want to show the information of these resources which is created. So for that we have this Terraform state show and then the name. So for the bucket we can just copy this, paste it, and if we do this one, so you can see the all the information about the resource, like extra information, like we have the ARN bucket, you have the domain name as well. If the EC2 instance, then you will get the IP address and all, also everything. So these are the information which you are getting from the state file, okay, for a particular resource. Next we have the rename. So sometimes you need rename a resource, and why renaming is important, I'll just tell you. So basically, it improves your code readability, right? So maybe you like here, it's basically wrong, the name of the resource. If anyone try to read your file, this Terraform file, so they will not understand why this is being used. So for this, like we can change the name from name to something like name like dev bucket or something like that. Okay, so let's do it. How we are going to do now? So for that, the command we have the Terraform state mv and then the old one. So what is the old name we have? So old name was S3 bucket. Let me just go. Okay, I can't. Let me just check in the state file itself. We need to give dot only, I guess. Dot name and then another name we are going to give, that is the AWS underscore S3 underscore bucket dot dev bucket. Let's hit enter. And here you can see it's moving to the move the name from name to dev bucket. Here if you see in the state file, so here it has been changed to dev bucket. So the what the benefit you got here, so in suppose if you are not aware of this thing, so again you had to destroy the resource and then create it again, and then you have to change the code here. So because of that we do it. Okay, so you can just change here also, no issues. Dev bucket, but there is no need to destroy the resource. Next we have the RM, so Terraform RM and whatever the state, so whatever the resource you have, so that you can use it to just remove the resource. And if you don't want Terraform to remember that, in case like that resource is like you guys are facing any error or something like that, so in that case you can use that Terraform state RM and then the whatever the resource you want to delete. Okay, that I'm not going to do, as I'm just going to destroy this whole thing which we created. Okay, so these are some four commands related to the state file management. So I hope it might help you, and that's it for this class, and I'll see you in the next one. Thank you so much for watching. Hey everyone, welcome back, and in this class we're going to create a basic project into AWS, that is the AWS VPC. Okay, so if you're not aware of VPC, I will just tell you in short. So VPC basically stands for the Virtual Private Cloud. Okay, so it basically acts as like a private network for you guys. Okay, so if you're in a project or in any project and you want to create your own kind of network, and you want to create your resources into VPC, or you want to keep those resources as a private, you want to use it just for the internal processing something, you don't want to make it publicly available. So in that case you can just create a VPC and you can create all your resources which you want to create into that. So I will just give you a quick diagram how it will be. So suppose you have a region. Okay, so AWS in region basically like data centers. Okay, so this is the suppose we have the US East region. Okay, in this US East region, suppose you are creating a VPC. So it will be your virtual private network. Okay, and also in VPC we have some components like if you have a VPC, so you create first subnets. Okay, in subnets you can have any. You can have public, you can have private, you can have both. That's completely fine. Any subnet which you want to create any kind of. So we will be creating basically public only. Then you have route tables. Okay. In route table you will define the routes how the traffic will go. Inside route tables you will have the routes. Okay. And then you will be having the gateways. So this also is having two kinds of internet gateway and the NAT gateway, and we are going to use only internet gateway as it's free, and NAT gateway if you use it will cost you. That's why I'm not including this into this class. Okay, so I will just let you know how it will be. So suppose this is the your VPC, and in VPC you can have subnets. Okay, suppose this is the subnet in region 1 and this is the subnet in AZ2. Okay, in subnets you can have any resources, like suppose I have a EC2 instance and here also I have a EC2 instance. So this subnet you consider as the public and this one you can consider this as a private subnet. So subnet is basically the part of the network. So whatever VPC you will be creating, you will give some network range of private IP ranges like 10.0.0.0/16. So with 16 shared block, you will have from 2 raised to 16 IPs you can create. Okay, so and then you can divide this subnet based on this particular shadow blocks. Okay, so next what we have, mm, so this is the EC2 instance and this is publicly and you want publicly available. So if anyone want to access that, so or this EC2 instance want to access the internet, so it this traffic will go through the internet gateway. Okay, and then if you are using private and if EC2 instances have been created in the private instances but you don't want to use the internet, you want to keep the connection private, so in that case you will be using the NAT gateway. Okay, so in this way like our VPC basically works. So for our use case what we are going to do, we are going to create a VPC, we're going to create a subnet, then public subnet, and then route table, then routes, then gateways. In gateways we will be creating internet gateway. So these are the things which we are going to create. Okay, and also the state management which we will be doing, that is the remote state only, which we have already done in the previous classes, but still in this class I'm again using it. So I have this bucket and the DynamoDB also available, so you can also create. Okay, so okay, let's move on now to the practical side. So we are just going to create a folder with Terraform workspace, not workspace, Terraform VPC we can write. Okay, let me just clear. Hmm, here I'm just getting a folder with Terraform AWS VPC. Okay, and here we are going to just Terraform AWS VPC. Okay, cool. Clear the screen, and then here what we are going to do, we will be first creating a workspace with Terraform workspace list. So currently it will have a default only. We can just create with new dev. Okay, so if I do list, so we are on the dev workspace. Cool. So now what I have to do, let me just go there where it is. Okay, here we will just create a file. I'll be creating some files, like first we will be creating main.tf, then we have provider.tf, sorry, then we can have variables, provider.tf, Then we have variables dot tf. We want to keep some variables also. Then we want to have some outputs dot tf. Then we want to have some Terraform dot tf to pass the values for the variables. Then we can have that last anything like backend dot tf for the remote state. Okay, cool. So for backend.tf, already I have created a video on this. So we have a separate class, and here this one I'll be using backend.tf. So we just copy paste things here. Okay. Just I will be changing the bucket name. So bucket name we can just define into the variables here. So we can have variable, then we can give the bucket name, and then here also bucket. Okay. So we can give the type equal to string. Okay, cool. Then in Terraform dfvars we can pass the bucket name actually. Bucket name equal to, so the bucket name I have here is my bucket 632255. So I can just type it here, my bucket 622255. Cool. Just save it. Then again we have variables.tf. In that also I will be creating some more variables like variable region underscore name. This also will be typed with string. Other variable what we can have, we will be creating variable with the name of what we can create. Okay, we have some DynamoDB table, right? So variable DynamoDB underscore table. So this also the type will be our string only. So we can just write type equal to string. Okay, so these two more values will be passing here. So we have this region name that was basically US East 1, and then we have DynamoDB table that we can get it from the backend.tf. Yes, Terraform remote table hopefully I'm using, or I need to just check in tables what it is. Okay, it is some Terraform logs. Okay, we can just give the same name. Where is, okay, Terraform logs, right? Okay, so this is fine. Now we will just use these variable into this backend.tf file. So bucket we can use as what dot bucket name, right? So just clear this var dot bucket name. And we have the DynamoDB, so we can give as var dot DynamoDB table. Then we have region, we can give it as was dot region. Cool. Then we have provider.tf. In provider.tf we can take it from anywhere. We will have here down somewhere. No, this one we can use. Yeah, scroll up. Okay, provider.tf is also done. Then next we have outputs. So output we can keep anything like we can provide for now output region name, and then we can give the value as var dot region name. Okay, so output done, provider done, tf was done, variables done. Okay, So in main.tf, now the what we are going to do, we will be creating a VPC, right? So you just go on the Google, and if you type like AWS VPC Terraform, you will go on to the website of Terraform registry. So from here only we will take the codes. You will see the syntax also, and also you will learn how you can just do the Google and you can get the things done. So just copy this one, just go here, paste it. So here I'm using a shader block of 16. Instant tenants I don't need for now. I will just remove it. And tags name is there, that is fine. We can give the name as VPC TF, that is the Terraform. Okay. So VPC will be created with this name and with this shader block. And then next what we will be doing, we'll be creating a subnet. So now next search for the AWS subnet Terraform. So for this also you will get here. You can scroll down, and here you can see you can provide it for the subnet VPC ID and the CIDR block and also the name. So even if you do here the same thing like resource AWS underscore subnet, then we can give as subnet. We can give it as name as the public subnet actually. Okay, so here we can provide the VPC ID with the AWS vpc.main.id code. Then we have the CIDR block, so that also we can give as 10.0.0. Sorry, 1.0 slash 24. So it will have some 10 2 raised to 8 IPs. Okay. Then also we have tags also here. So just copy this thing and I will paste it here. Name we can give as public subnet. Okay. So we have created the subnet. Then we have in subnet we want to like uh, create a route table, right? So we will be creating that also. You can do just resource or AWS underscore route underscore table. So there's difference between route and route table. Okay, so route table we will first create, and inside that whatever route we will be create, that will be AWS routes. Okay, so route table we can give here. Just remove it. Here also you have to provide the VPC ID, I guess. Here something mistake is there, I guess. Let me just create it again. Route underscore table in name route table, and then VPC underscore ID. The same we can give VPC main dot ID, right? Here you can give the name as public route table. Okay. So if you search this also you will get so AWS route table Terraform. If you go down, or here also you can see from the Gemini VPC we can just pass it. Next we have the route also. Here you got the route also. So resource it is route, internet route, destination you can see, and the gateway ID for this internet gateway. Okay, yeah. So first we'll be creating a internet gateway also. So resource AWS underscore internet gateway IG we can give, and then here also we need the VPC ID. So where we want to create our internet gateway. So in this ID we want to create. Then we can give the tags with name, right? Name we can give as internet gateway TF. Okay, so that is done. Then we will be having the route. So let me just copy this thing. Okay, so here we can just have the route table. Can just remove this all. AWS underscore route table dot ID. And same here we will have internet gateway dot ID. Okay, cool. We'll just remove this. Okay, so now we have almost everything. VPC we have, subnet we have, route table we have, internet gateway we have. Then we have the route also, right? Okay, so that's nice. So what are the things we saw here? Okay, subnets, public, route table, route, gateway, internet gateway. Yeah, all done. Okay, cool. So now what we are going to do, we are going to simply do a Terraform plan, and it failed. Why it failed? Let me just check. Sorry, we need to do first initialize, right? I didn't initialize. Okay, so here it's failing somewhere at backend.tf what dot region. Why variables not allowed? Okay, we can't give the variables. That's fine. I'll just remove it. Whatever it was here. If I do control it, will it work? Yeah. Okay, here we have just provide the Terraform logs, right? Okay. So main.tf outputs. Okay, in outputs we will be providing output of all the required things. Output VPC ID we can give value equal to AWS underscore VPC main.id. Cool. Next we can provide ID for output subnet ID. Then we have output equal to AWS, sorry, value equal to what we have here AWS underscore subnet public subnet dot ID. Okay, this one will be just printing. So let me just do now Terraform minute. Okay, we got some error. Uh, the parameter dynamo db is replicator use parameter use log for instance. Okay, failed to get existing workspace s3 my terraform log 6547 doesn't exist. Okay, where it is. Yeah, so bucket name I have to change. My bucket 632255. Okay, let me just I can copy from variables now. TF4, right? Simply just remove it and paste it. Yeah. Okay, now let me just initialize. That should be done now without any issues, hopefully. Okay, initializing provider plugins. So it will take a few more seconds of time as we are using the remote state. So it will take some time. Till then, I'll just pause and I will come back. Okay, initialization is done. Now it's time to plan. Okay, acquiring state lock. This might take a few minutes. Okay, plan is done. Now we have to apply. So you can see VPC ID, subnet ID is the name we get to know. And we have how many changes? 5. Okay, here you have to just enter yes, and you can see VPC is getting created. Oh, creation completion. Okay, done. Internet gateway route table. Oh, nice. So everything is done. We have, you can see the subnet ID, VPC ID. So all resources has been created. If I go back here into my console and if I search for here VPC, so I should be able to see my VPCs. So in my your VPC, I will go. Okay, it's loading. Okay, cool. So here you can see the VPC TF. So if I click on VPC ID, you can see all the information right here. So you can see the flow also, like the source map. This is the VPC. This is the subnet which you have created, and this is the route table. That is the it gets created every time. Okay, and then we have this public route table TF, and it is connected to the internet gateway. Okay, but one issue we have here is like this public subnet is not connected to this route table, so that also needs to be done. So let's do it. Okay, so for that we have one AWS route table association. So resource AWS underscore route underscore table association. Okay, what happened? Something happened. Resource AWS underscore route underscore table association. Yeah, name we can give route table RTA. So here we can provide the VPC ID. So VPC we have here as okay. Oh, we're giving VPC ID only, right? But why it's not showing me? Okay, let me just check what it is. We can just do Google here. Route table association Terraform. So here what we have subnet ID and route table ID. Okay, so we can just go here and give the subnet ID. Yeah, AWS underscore dot ID. Then we have then route table ID. Route table dot ID. Cool. Now I'll just apply and then it should work now. So if you will see our VPC, then it will you can see the mapping there. Requiring state lock. Okay, refreshing state. Want to edit? I can see now here. Okay, it is done. Okay, let me just go back here on the screen and let me just refresh. So if I will refresh here, I should be able to see that particular route. Okay, so if I go here and now you can see the resource map as public subnet, which is associated with my whatever route table which I created, and that is getting attached to the internet gateway. Okay, so in this way you create the VPC in our using the Terraform. So that's it for this class, and I will see you in the next one. Thank you so much for watching.